much for inviting this paper. It's a pleasure to be here. So this is joint work with Harald Uhlig, who is at University of Chicago. And this is basically the second paper in a broader research agenda on what we can say about crypto prices in competition to more traditional fiat money. So, better, I hope. Okay, so just to give you an idea about what we have in mind when we talk about competition between currencies. So, for currencies, we usually say they have different functionalities. One of them is they serve as a store of value, and the other is they serve as a medium of exchange. And generically, if you have several currencies at hand that can function this way, then expectations about future price evolution play a role in the following sense. So if you believe that one currency is going to increase in value or devalue slower compared to the other currency, what you're going to do is that you're going to use the devaluing currency in order to purchase goods, while you use the currency of which you believe that the value is more stable to store value. Yeah, that's the interaction. And yet, in macroeconomics, we believe that prices for currencies have to change in a way such that supply equals demand. Okay, and so what we would like to do is to make statements or derive implications for cryptocurrency prices under specifically accounting for competition to, for instance, the dollar or the euro. Why is this interesting? Because for the dollar or the euro, we know that there's a central bank behind this currency which stabilizes the price, while for instance, Bitcoin, there's no such stabilizing institution. Okay, and this, we believe that the stabilization of the central bank has implications for cryptocurrency prices. And let me be a little bit more specific what we mean with cryptocurrency here. We talk about fiat monies, which means these are currencies which have no intrinsic value. So we do not talk about equity tokens or utility tokens. Yeah, we talk maybe about Litecoin. You can also think about pebbles and yellow post-its. It's an intrinsically worthless object, similarly to the dollar and the euro. Okay. And so the paper today looks at how transaction costs matter for cryptocurrency prices. And so we abstract from a lot of details, namely we no longer model in specifically the mining incentives and the interaction between miners and users. We only look from the user's perspective, who can choose between currencies, which currencies to hold for storage reasons, to preserve value, which currencies to use in order to purchase goods. So this is that's a user perspective. And the question is, so how does the functionality of a medium of exchange and the storage of value interact in combination now with transaction costs? So with transaction costs, we talk about mining fees and so on, but there's also transaction costs involved with dollar purchases, namely a value-added tax. Okay, and so the concrete setting today is dollar as a representative of a central bank controlled currency versus Bitcoin as a representative of a fiat cryptocurrency. How do they interact with one another? If there are differences in transaction fees, and if we allow for exchange between Bitcoin to dollar and vice versa. Okay, and so how do we think about currencies here? They are no longer perfect substitutes, but we think about, so how do they differ in terms of differentiated goods? We say that some goods are more costly to purchase with Bitcoin as opposed to dollars. And the case that we have in mind is a pizza home delivery versus cocaine. Okay, so the concrete question is, how do asymmetries and transaction costs between money drive currency substitution and the usage for Bitcoin and dollars? And I will be much more specific in the sequel. So for time reasons, let me briefly mention, we are very much related to the paper by Carrican and Wallace and its stochastic version, Manueli and Peck, who talk about currency competition. And then I should also mention we contribute to the theory of money, and there are papers on Bitcoin pricing and transaction costs, for instance, by Bruno today. Okay. So let me jump into the model. We say that time is discrete and infinite, and the economy is completely deterministic. So there is no randomness involved, which really boils everything down a lot. We assume that there's a continuum of differentiated goods, and these goods are perishable over time. So you cannot store value by holding on to goods. Think of these goods as apples, bananas. They decay within a couple of days. Yeah, so you cannot store by holding on to goods. And there is an infinity of goods given in the interval from 0 to 1. There are two different kinds of monies, which we call Bitcoin and dollars. And so how do they differ? The dollar stock is governed by a central bank. The supply can go up and down, and the Bitcoin stock is not. There are two types of infinite-lived agents, green and red agents, and they interact with one another in a way such that there is a role for money in this economy. So I will explain this to you in a picture because I think this is more helpful. We assume that time is odd, even odd, in terms of their time periods. We assume that in odd time periods, only green agents can produce these goods, and only red agents would like to consume. So green agents are not interested in consumption. But now remember, the goods decay from time period to time period, meaning that green agents who produce will have to sell all the goods within this time period to the other side of the market. So there's a reason to trade using money. In the next time period, the roles are going to switch and only red agents can produce and green agents want to consume. And then again, the agents that would like to consume, here the green agents, will need to use the money that they had as an income in the previous time period to purchase goods in the next time period. Yeah. So the only reason to acquire goods is through having earned money in the previous time period. Okay. So how are goods then different? So currency usage is costly, and we assume that there's a dollar transaction cost 1 minus gamma. This cost is going to differ in the kind of good that is to be purchased. Similarly for Bitcoin, there's a transaction cost 1 minus alpha k, and this cost varies according to the good that you would like to acquire. Then we make an assumption. We say that alpha over gamma of k is a strictly increasing and continuous function. This basically says that the goods that are in this interval from 0 to 1 are strictly ordered in how much more costly the good is to acquire in Bitcoin as opposed to dollars. Yeah. And I will be more clear about this in a moment. It's just these goods are strictly ordered in terms of their costs, how to acquire them in Bitcoin as opposed to dollars. Yeah. So far, only notation. Then there are goods prices, P and P hat. For consumption goods, P is the price in dollars, P hat is the price in Bitcoin, and these are now before transaction costs. So in order to acquire 1 unit of good K, you have to pay P over gamma K dollars or P hat over alpha Bitcoins. This is taking into account transaction costs. Okay, so now how do we imagine exchange to occur? There's an exchange fee from Bitcoin to dollars and backwards, so you will have to pay the fee either way. We call Q the buyer's shadow price, so the amount of dollars she's going to demand in return for 1 Bitcoin, and Q tilde is the shadow price for the seller. And since here the economy is fully deterministic, we know that the seller today is a buyer tomorrow, so her shadow price Q tilde today is going to be the buyer's shadow price tomorrow. Yeah. Then there is an exchange arbitrage condition. It has to be that the seller today, in return for 1 Bitcoin, requires strictly less dollars than the buyer, otherwise there would be infinitely exchange. On the other hand, however, if the buyer demands many more dollars than for 1 Bitcoin as the seller, then there's no exchange at all. So exchange only takes place if the buyer and the seller demand an equal amount of dollars for 1 Bitcoin. So if QT is equal to QT tilde. Nevertheless, the transaction, also the exchange fee is going to lead to a symmetry in the exchange fee that is incurred by the buyer versus the seller. And so let me explain this to you a little bit more in detail. So assume that the goods buyer is going to give up 1 Bitcoin in return for dollars. This is the first case. Then we assume that the seller is going to receive the Bitcoin in full. The buyer is going to incur the transaction fee. Namely, so the good seller is going to send back QT tilde dollars. That's her indifferent price. 1 minus phi Q tilde here. That's going to be the transaction fee. And the goods buyer receives phi Q tilde dollars in this exchange. So phi Q tilde has to be the shadow price from the perspective of the buyer. Now things are different if the goods buyer would like to receive Bitcoin in return for dollar. So assume that she sends QT dollars to the goods seller, then again the dollars are received in full by the seller. The seller is going to send back 1/5 Bitcoin in order for 1 Bitcoin to arrive. So there is a symmetry in the costs here, which will play a role in a moment from now. Okay, so more notation, we say that the aggregate dollar price index, PT, is given by this integral. We assume that there's a central bank which governs the path of the price index. There's a target inflation rate by the central bank, and then there are stocks for Bitcoin and dollars. Important for the timing is we assume that currency exchange and goods purchases occur simultaneously. This means an agent can, or a buyer can, purchase or spend all of her Bitcoins for consumption goods. Then she has some dollars left, can exchange the dollars for Bitcoin and purchase more in Bitcoin. This is all within one time period. So this exchange and goods purchase happen simultaneously. Okay, so we start the analysis now. From the perspective of a goods seller, she can set the goods prices for Bitcoin and dollar purchases. So for every good K, she is going to set the price in terms of dollars and Bitcoin such that she is indifferent between receiving either currency. This means that this price ratio here is going to be the same for all goods K. The prices themselves, for every good, the price in dollar and Bitcoin can vary, but the ratio has to be the same for all goods. Okay, and this is exactly the competition that you can see here going on between the currencies. The seller can decide how to set the price, and the seller is going to set the price in a way such that she's indifferent between receiving either currency. Okay, so what about the buyer? The buyer will have to purchase goods and will incur the transaction cost. So for 1 Bitcoin, the buyer buys alpha over p hat units of good K. For Q dollars in return, she's going to purchase Q times gamma over P units of good K. And remember, at Q dollars, she's indifferent between having these Q dollars and 1 Bitcoin. So at some critical good K, which is defined this way here, she's going to be indifferent between purchasing this particular good in Bitcoin as opposed to dollars. So this is how we pin down currency substitution. At this particular good, the buyer does no longer care which currency to use. And remember, we can replace now the term on the right-hand side. This did not work. This term here by the QT plus 1. Okay, we just plug this in equilibrium. The price ratio has to be equal to QT plus 1, so we receive this equation in equilibrium between buyer and seller, which pins down the critical good as a function of transaction costs in Bitcoin and dollars and the exchange rate. So this is the change of the exchange rate, or 1 over the exchange. Okay, what does this mean in a picture? At the critical good, the agent is indifferent. All goods below the critical good are purchased in dollars, and all goods above the critical good are purchased in Bitcoin. And this will give you directly the demand for currency. Will give you directly the demand for currency. We have imposed the strong assumption that alpha over gamma is strictly increasing, which gives you uniqueness of the critical good if it exists. It can be that the critical good is located at the boundary such that all purchases occur in Bitcoin and dollars. And then, so purchases may occur only in Bitcoin and dollars, but remember we have the exchange going on such that agents are going to nevertheless use the other currency. Okay. So how do we pin goods prices? We will see that goods prices are fully determined by the critical good and the transaction costs. So generically, both goods are provided in the same supply and are therefore also consumed in the same amount. Therefore, the dollar price, after transaction costs, they have to be identical. This is simply marginal rate of substitution has to equal the price ratio and the way the CAS aggregator is set up. So this means that for all goods that are purchased in dollars, there we go, okay, here. This price ratio is given simply by the transaction costs. Similarly, for all goods that are purchased in Bitcoin, we have this ratio. And in particular, we can use for K prime the critical good itself here and here, implying that the goods for all goods in Bitcoins and dollars, the prices are given solely by the prices of the critical good and the transaction costs. So if you know the critical good and the transaction costs, all prices of all other goods are pinned down. Okay, so now let's go to currency demand. In equilibrium, there's market clearing, meaning that all goods are going to be purchased because they perish over time. And we know that all goods below the critical good have to be purchased using dollars. All goods above the critical good are purchased in terms of Bitcoin. So we can directly compute the demand for a currency of a buyer. So how many dollars in Bitcoins is she going to spend on her total purchases? And so we derive at these two formulas here. So the total spending in Bitcoin is given by, is fully put down by the price of the critical good, the transaction costs, and production in the economy. So this is where market clearing comes in. Under currency competition, prices have to adjust such that demand equals supply. This is the total supply of goods in the economy, and the supply is going to determine how many dollars in Bitcoins are going to be demanded by the buyer. Okay. Now, the buyer has to be careful to not spend more dollars in Bitcoins than she has. So looking at the budget constraint, the total quantity of dollars spent by a buyer has to be below the dollars that she has from her last time period, the transfers by the central bank, and the amount of dollars that she received or gave away due to the exchange. The same for Bitcoin. She can only spend as many Bitcoins as she has from the last time period, less or more what she exchanged for. So these are the budget constraints. And we say that for delta strictly greater 1, this just means that the buyer is selling Bitcoins in return for dollars. And for negative delta, it's the other way around. So what are savings? Savings in terms of currency is if the total quantity of dollars that are from the time period beforehand, transfers and exchanges, less the amount of dollars spent on consumption goods. This is the savings in terms of dollars. So this is going to be taken to the next time period. And the same for Bitcoin. And yes. It has to be positive. Yeah, there's no shorting. But I'm not sure whether it's relevant. Yeah. Okay. Okay. So how does exchange happen? So I think we do not need that. Let me think about that. Okay, so what if the buyer enters the period with amounts of dollars in Bitcoins, which differ from the intended spending with either currency? So in case 1 here, the buyer would like to spend more in terms of dollars than she has from a previous time period, but she would like to spend less in Bitcoin than she has from the previous time period. So what she's going to do is she wants to acquire additional dollars. And how to do it? Well, by transferring Bitcoin, okay? So the buyer is going to enter the exchange and transfer Bitcoin for dollars. This means exchange is taking place, but then it has to be that the exchange rate QT plus 1 is equal to so tomorrow's exchange rate is equal to exchange rate today corrected by this transaction cost, yeah. But now we know QT over QT plus 1 is going to pin down the critical good here. So this is how we get the critical good. It's here. Sorry for that. So the critical good is going to solve this equation here. This just means it's pinned down by the transaction fee and the transaction cost. What if it's the other way around? So if there is more Bitcoin, so the buyer would like to spend more in terms of Bitcoin than she has, and less in terms of dollars, then the exchange is going to take place the other way around. But now the exchange fee is going to be different, yeah? So one can show that the exchange rate today is then equal phi times the exchange rate tomorrow is equal to phi exchange rate today, meaning that the critical good is going to be different, Yeah, so the critical good is going to depend on in which direction exchange is going to take place, because the exchange rate is asymmetric. So there is, depending on the direction of trade, the critical good is going to jump, and also the total currency demand is going to jump. So there's 5 minutes. Oh, I'm almost done. Okay. So what if exchange is not desired? So if the total quantity of dollars and bitcoins that the buyer would like to spend is below what she has, then there's no exchange necessary, and the critical good is going to be located in some interval. But all over, let me sum up the insights from this model. So first of all, currency demand and substitution is going to depend on the production in the economy. This comes through the market clearing condition or through economics. So the total quantity of Bitcoin and dollars depends on the total production. This is because the goods perish, so the prices are going to adjust such that all goods are sold every time period. Yeah. So the total demand for Bitcoin and dollar is going to vary in the total production of the economy. But not only this, but they also pin down the critical good. If the critical good, in general, it has to lie in some interval, which is bounded. The bounds come from the no arbitrage exchange condition. If exchange takes place, then the critical good can only take two values. The critical good can jump across time between these two values. But if the exchange fee is 1, you see that these two values collapse to one value. The critical good is therefore constant across time and independent of aggregate consumption and independently of whether exchange takes place or not. Moreover, the exchange rate process Q is going to be constant despite the transaction cost and the segmentation in goods. So a constant exchange rate, we know this result already from Carrick and Wallace. So basically, this is a version of Carrick and Wallace then under transaction costs and goods segmentation. Yeah. So let me wrap up. How do transaction costs and exchange fees determine currency usage under currency competition? Well, we have trade in differentiated goods and heterogeneity in goods through transaction costs with exchange fee. If the exchange fee is equal to 1, then despite having transaction fees, the exchange rate is going to be constant. What does this mean? The central bank is going to impose an inflation level. This inflation level is going to pass through the cryptocurrency price, will be identical. Yeah. So Carrick and Wallace strikes back. Thank you very much.
Sorry. So you start solving the model by assuming that by discussing how the sellers are indifferent,
yes,
and that you pin down the condition. But then you say that the buyer, so basically you show us that the buyers are not indifferent because they have some preferences for Bitcoin over dollars, and depending on the stock of their existing Bitcoin of dollars, then they may incur some fees. So, but then the seller will be buyers. So I don't understand how they can be indifferent. So I may have missed something, but I understood that the seller anticipated they will be buyer next period. They will need certain stock of dollar and Bitcoin, and therefore they may actually not be indifferent when they are on the selling side. So anticipating that they will be buyer, they may have certain preference to having certain amount of Bitcoin or dollar, which means they're not indifferent.
Okay, so these are different conditions will be imposed on every time period. That's the first thing. So then the second thing is, you're right, the seller imposes indifference between prices, and the buyer in return is going to react to that. So the buyer is not going to be indifferent, and then the lack of indifference for the buyer to purchase for some goods. So here, and so on the left-hand side of the critical good, the buyer is not going to be indifferent in purchasing between Bitcoin and dollars.
Correct,
yeah?
But the seller will be a buyer.
Right. And
so how can the seller be indifferent, anticipating that he will be a buyer and the buyers are not indifferent?
That's the next time period.
Correct.
So yes. No, so this is within time period. So within one time period, the seller sets price to be indifferent, the buyers.
Very well, but then it means that the equation that specifies, if I anticipate the next time period I will not be indifferent, I will not be indifferent today as well, and therefore I'm not going to set the equation that you use to then solve the rest.
So that's, I think that's fine. Yeah.
Today,
yeah.
Anticipating not to be indifferent tomorrow.
Why?
Well, let's think about a situation in which you play a bargaining game.
Okay.
What period you make an offer?
Yes.
given period you accept it all.
No, but that's a different story because here is a stock. You need a stock of Bitcoin and dollar to accumulate today for then transacting tomorrow. Tomorrow you won't be indifferent. Your utility will depend on the stock that you have. So how can you be indifferent today?
So it evolves forward. You can think of it starting at time 0. You start with a certain stock of Bitcoin and dollars. These are given. And then you have to form prices for how to charge today. This is all going to affect your Bitcoin stock tomorrow, but you have the initial stock with which you start, you cannot change. You take this, and then it evolves forward.
Depending on how many Bitcoin and dollar you receive. Okay, we can continue later. Sorry.
No. But you start with a specific stock of Bitcoin and dollar which is given to you. This is you cannot change, and from this starting point which you cannot change, the prices are going to be set in a way such that buyers and sellers are indifferent, and then it evolves forward. So the stock evolves forward in time.
Another question.
So mine is really a clarification question. How exactly do you model the transaction cost on these goods? Because there are different ways. One is to have some transaction cost as fees that are paid to some agents. One is to have some goods that disappear in the process, or potentially some money that also disappears in the process.
Yeah.
So can you be more clear on that?
Yes. So I think the starting point for the analysis is to believe that some goods are more costly than others. If you believe that there is like a uniform transaction cost for all kinds of purchases, you would layer this on top of all goods, for instance. So for instance, the likelihood that you lose access to your wallet applies uniformly over all goods. It's not good specific. And then gamma and alpha are good specific costs.
Yeah, but so it's not still clear to me whether you see that as in terms of the explicit modeling assumptions, whether it's a part of the good that disappear, so iceberg type of cost, whether it's something that is paid in utility terms by your agent, or
Okay.
I'm wondering about the
Okay, so I should say the costs do not enter the utility function. That's I should say. They are all like occurred in monetary terms. Yes.
So if they are incurred in monetary terms,
Here.
are they paid to some other agents?
They are paid, yes. So that's something that I cut out in the interest of time. So the fees or the costs, they do not disappear in the system. They're all allocated to the seller. So thank you for the question to clarify this. The costs do not vanish out of the economic system. They are all distributed to the seller, who can then, as a buyer, use this additional source of income in a way. We needed to find a way to redistribute the transaction costs and exchange rate fees. Yeah, so. Yes, that's not happening here. Yeah.
Okay, we must go to
Yeah.
the next paper. Sorry.
Just a quick question, maybe. No, just a quick question. I want to understand how is different from.
No, we respect timing.
We can talk later.
It's just to understand how is different this model from bimetallism. So,
Say again?
yeah. So how is this model different from bimetallism? I mean, the classical theory. You know, there's a huge literature in the 19th century about the time we were using gold and silver as two currencies.
Yes.
You know.
Yes. Okay.
And the classical study of Copernicus' Gershom law.
Okay, so it's different in the sense that, for instance, gold, germs, and so on, we would believe that they satisfy another purpose, similar to utility tokens.
The mathematical model, I don't see any difference.
There are models where you have money in the utility function, and we abstract from this. So here we have no money in the utility function. This is why you could not use gold, because it has a secondary value or secondary usage as using it for production of jewelry or something like this.